Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 13 in our incredible new Arduino tutorial series where we're going to teach you to be an Arduino programmer and an engineering whiz person. I started to say whiz kid, but I know that there are some of you older guys out there following this tutorial. So I hope all of you guys will learn something today. Very important lesson. We are going to learn about Arduino if statements. So I need you to pour yourself a big mug of iced coffee. I need you to get your most amazing eLego Super Starter Kit. If you don't have one yet, this is the kit that we are using for this entire magnificent set of tutorials. Look in the link below, hook a brother up and order your kit there. 35 bucks, and this is enough components to keep us busy for a long time. Okay, so what we are going to learn today is we are going to learn about if statements. But to do that, we are going to go back to what we had worked on in lesson number 12, which was a potentiometer. So we're going to teach you about an if statement, but we're going to teach it to you using a circuit and a little simple project based on a potentiometer. And so if I come over here, what I want to show you is I want to kind of show you a little bit of an introduction about an if statement, and then we're going to come over here and build a circuit and do some coding. And this is something we talked about very early on, and it's kind of the idea of like a clause in an Arduino program. And so far we've had like two types of clauses. The first type of clause was a void setup. These are things that you're going to do one time, and the clause begins with a curly bracket and it ends with a curly bracket, and any commands that you put between those two curly brackets are in this clause. The second clause is a void loop. It begins with a curly, ends with a curly, and any commands that you put between those two curlies will be executed over and over because you sit in loop there. There are other clauses, and the clause that we are going to learn today is the if clause or the if statement. And those are statements that are only executed based on a condition. Okay, they're statements that are only executed if a certain condition is true. So let's just jump right in and get busy here. And I need to figure out my most suitable shot here. Which is the most suitable shot? Let's work on this one for right now. Okay, you remember in your Arduino kit, your most excellent Arduino kit, I'm just going to kind of start over here on this, okay? In your most excellent Arduino kit, I am like too small there. I don't want to completely disappear on you. There, how you like that? Okay, you have a potentiometer in your kit, and we talked about, excuse me, we talked about how to hook up this potentiometer in lesson number 12, but we're going to start again. I'm going to go through this fast, and if you can't keep up, go back to lesson number 12. But we plugged this in with the two. It's hard for me to see. We plug it in with the two leads right above that center trench, and then the one lead right below the center trench. All right. What did we learn? And this one is a little hard to plug in, but if you mash it firmly, it will go all the way in. Okay, so what do we need to do to hook it up? Well, we need to hook 5 volts across those outside or top leads. And so I have a red wire here connected to the 5-volt pin on the Arduino. It will come to the left pin, or my left pin. Okay, and then I will get ground. The ground pin is next to pin 13 here, and I will hook it to the rightmost pin. And then I'm going to read the voltage off of the center tap, and so I'm going to hook that up down here to the center tap. And now what will happen is this voltage will vary. If I turn it all the way to the left, it should read 0 volts. If I turn it all the way to the right, it should read 5 volts because I'm going into pin A2. So let's set that program up really quickly. You did this in the earlier lesson. You might ask, why are you repeating? Well, it's just like sometimes reviewing stuff is good. So I'm going to go real fast this time. I'm going to go real fast this time because we have done this before. And I need to switch over to a shot where you can see what is going on here. I think this would be a good shot. All right. So we are connected to a pin. We are connected to a pin, and so we are going to say int, and then that pin is going to be my pin, let's say, and then that is going to be A2 because we're connected to A2, semicolon. Now we are going to be reading a value from the potentiometer, so that's going to be int. We'll call it read val. And that is going to, we're going to read that, so we're not going to put a value into that. We just got to declare it, okay? We're going to convert that to a voltage, and the voltages might be the in-between numbers. And so we're going to make that a float because it might be a decimal number. And we're going to call that V2 for voltage 2. That we are not going to put a value in initially because it is going to calculate that. All right, what else will we need here? I am sure we're going to need something else, but we will come down here, and when I figure out what I'm forgetting, then I'll go back and put it in. We want to print out to the serial monitor, so we need to set it up, serial.begin, happy orange color, and that's going to be a baud rate of 9600. Again, doesn't matter what baud rate you use, but your serial monitor has to use the same one. Now, what will we do? We are going to read from the potentiometer. We are going to convert that to a voltage. We're going to print it, and then we're going to delay. So let's do this somewhat quickly here. Let's try to do this kind of quickly. So what do I want to do? Well, I want to say that read, that was not good. Okay, read val is equal to analog read. One parameter, what is the parameter? Where am I reading from? I'm reading from my pin, which was A2. Now, what is V2? If you don't remember this, go back and look at the old lesson, but remember that the voltage off of the coming off of the potentiometer can be between 0 and 5 volts, but the Arduino doesn't read from 0 to 5, it reads from 0 to 1023, so we have to scale 0 to 1023 to read to, we've got to scale that to the real world voltage value, which is 0 to 5, and so we've got to do that. V2 is equal to, and we are going to have 5 point divided by 1023 point. Why do we have to put those points in there? Because we've got to force it to do floating point math. 5 is an int. If you said 5 divided by 1023, 5 is an int, 1023 is an int, you would get an int answer, which is 0, and you would sit and pull your head out, and then you would throw your little Arduino kit away, and you would never come back. To do floating point math, you've got to make sure these are floating point numbers. So 5 divided by 1023, it needs to be 5 point divided by 1023 point. And then we multiply by what? We multiply by read val. And let's see, if read val was 1023, 1023 divided by 1023 is 1 times 5 is 5. And so if you're reading 1023, it converts to 5. If you're reading 0, it converts to 0. So this takes this number between 0 and 1023 and it changes it into the real world voltage, the actual voltage of 0 to 5. So we now have a real voltage. Let's make sure by printing it. So we're going to say serial dot println, misspelled it, println, and then what are we going to print? V2. Okay, and you know what I didn't do a real good job at last time? I didn't do a real good job at formatting. So I'm going to say here serial.println, and I'm going to print the, or just print, because I want to stay on the same line, print potentiometer. I hope I spelled that right. Potentiometer voltage is, and I put a space, end it, semicolon. Uh-oh, I didn't put a semicolon up here. I get in a hurry and I don't do that sometimes. And now we are going to pause. And so we will put a delay. And then let's say quarter of a second delay to 50, right? No, no, don't use constants down here. Use variables. And so I'll call it dt for delay time. And then I come up here and I need to set that up. Int dt delay time is equal to 250, I think we said, and that should be good. Okay, for you to see this, I think I need to go to a different shot. I think if I go to this shot, you are going to be able to see the serial monitor when I pop it up. But let's go ahead and download the program. Ooh, what does it not like? It does not like something here. Do I have... Oh, sometimes if you have the serial... Oh, I'm glad this happened, because sometimes if you have the serial monitor open already, you can't download the program. I am hoping that that was it. Let's try it again. Ah, yes, that was it. Serial monitor open. You need to close the serial monitor before you try to download the program. And now that the program is downloaded, we can open the serial monitor. And, oh, look at that. We are getting values out. Isn't that great? Potentiometer value is 5, okay. And that's all the way to the right. You see my hand now? I'm going to start turning it gradually to the left. And you see how smoothly that voltage on that center pin is coming down to 0. Back up as I turn the knob. So you see, boom, back up to 5. Okay, now what does an if statement have to do with any of this? What is this nonsense? Okay, let's imagine that you wanted to give a warning. Like, let's say that if you had a voltage over 4 volts, like maybe you shouldn't turn this to more than 4 volts. If you have more than 4 volts, you could generate a problem. So you need to make a warning. You need to warn the person if the voltage is above 4 volts. So what we're going to do is we are going to get into our most excellent kit. I need you to get a red LED out. So I need to find my little bag of LEDs. Why red? Because red is a warning. So we are going to use a red LED. Okay. If we are going to use an LED, what else do we need? We need a resistor. We need to get one of these 330 ohm resistors. Okay, so be getting that out as we talk. I've got several here, so I got to kind of look at the code. This one is a 330 ohm resistor. You guys, I hope you're keeping your kits neat. Keep your kits neat. Keep your components all organized. Okay, so let me move this away. And now we are going to build the circuit. A little more circuitry here. I am going to need a couple of wires as well. And so let me get a few wires out here. And now let's build the circuit. To build the circuit, let's switch to a more suitable view. I think this one will be more suitable. Okay, so we want the long leg of the LED. I'm going to put it in column 35. Okay, and yeah, let's see. I'm going to put it in 40. Long leg of the LED is in 40. Now I need a resistor, so the resistor is going to go one leg in column 35 and one leg in 40. And what does that do? That connects. Do you want me to zoom in? Okay. Let me see if I can focus it. So the long leg of the LED and the right leg of the resistor are both in column 40, which means they will be connected together through that column. Then I need to come to the top of the resistor, which is 35, and I need to take that over to pin 9 on the Arduino, let's say. Put it on pin 9. And then the bottom leg of the LED has to complete the circuit. And I've already used one ground GND. and I've used the ground over there by pin 13, and I could run the ground over and create a ground rail, but if I have an extra ground, I like to use it instead of trying to create that. And if you look, there's a GND up here. Okay, you see there's a GND right there. In fact, there's two GNDs there, so I'll put that like that. Okay, so I now have a warning LED in my circuit, and you can see how that's hooked up to pin 9, right? Let's come back over to our code. I love my circuit to be level. I don't like crooked things. And now my paper's crooked. Oh my, I'm going to go crazy. I'm going to go crazy. All right, I think that's pretty good. Okay, so now I'm working with pin 9. Now I am working with pin 9, so what do I need? I need int, and it's red. You can't see me. Let me come back over here. Okay, so now you can see that I am right here on int. Red pin is equal to what? 9. All right. So now I'm going to be using red pin. Ooh, you know what I forgot to do? I forgot to do my pin mode. I need to do that. That's very poor programming practice. Pin mode, and that was my pin, and that was an input. Okay. And now I'm going to do pin mode, and then what is it? Red pin, and that is going to be an output. Okay. Now, what does the program do down here? Well, it reads the analog value, it converts it to a voltage, and then it prints what the voltage is. But what do we want to do? We want to warn the user if they're getting over 4 volts and tell them that the voltage is getting too high. How are we going to warn them? We're going to warn them by turning the LED on. So what do we want to do here? We want to put in an if statement, and an if statement works like this. You just put in if, and then you put in what your condition is inside the parentheses. We'll talk about the conditions, and if that condition is true, you start executing this clause. A clause starts with a open curly, and the clause ends with a close curly. And notice that anything between this open curly and this closed curly, it put one in and I put one in. One of the things I don't like that the Arduino does, let me see if I can get it to do it because it really bugs me, and I could probably turn it off if I figure it out. But you see, I start an if statement and then I put the open curly, and when I put the open curly, for some reason, sometimes it will put in the closed one, but not this time. So I feel kind of silly. So now I'll have to put it in. Now what you have to see is this curly opens and closes. That's associated with the if statement. This open curly and this closed curly is associated with a void loop. So now anything that I put between this open curly and this closed curly will be executed if the condition is true. Well, what condition do I want? If V2 is what? Greater than 4.0. So if V2 is greater than 4.0, what do I want to do? Well, I want to say digital write, which pin? Red pin. And what do I want to do? I want to make it high. And then that needs a colon. Notice, or semicolon, notice that the if statement does not have a semicolon because it's not a command. It creates a clause, just like void loop doesn't have a semicolon, and void setup doesn't have a semicolon. So similarly, when we start this if statement, it's an open curly and a closed curly. How many commands do I put in there? 1. Digital write, red pin, high. All right. But now what you have to think is, you have to think that if V2, you got to turn it off, right? Because if you come in here and when it gets above 4, it's going to turn on. But then if you turn the potentiometer below 4, that LED is stuck on. So then you need to say if V2 is what? Less than 4.0, then open curly. And then you see when I hit enter, it automatically closed it for me. So you've got to be careful to not add an extra. And that causes a lot of confusion. I really don't like that. So if it's less than 4, digital right. And then what do we want? Red pin. And then what do we want? Low. We want to turn it off. And that one will have a semicolon. All right, this is pretty darn good. So what this is going to do is if we turn that LED to a voltage above 4, it should, if we turn that potentiometer to a voltage above 4, it should give us a warning and turn the red LED on. Okay, hold your breath. I'm going to hit the download. Ah, happy, happy, happy. Boom, it is working. Let's open up our serial monitor. I will need to go to this other shot here. And then I will need to open up the serial monitor. I hope the serial monitor opens. Oh, it's hiding down here. Okay, so look at that. Voltage is 0, voltage is 0, voltage is 0. The potentiometer voltage is 0, 0, 0. Okay, so now do you see I am going to very carefully start turning the voltage up. And you see we're up to like 0.7 volts. We're coming up to 1.5 volts. And then we're coming up, as I'm turning the potentiometer, we're coming up to 2.5, 3. I got to be real careful here. Oh my goodness, it went to 4. And what happened? The LED came on. Do you see 4.04, 4.05? The LED is on, right? So I better back off a little bit. And as I bring it right under to 3.5, the LED is off. As it comes above 4, the LED turns on. Boom! Do you see how powerful this is? Now all of a sudden, I can close the serial monitor and I can just sit and look only at the circuit. I don't have to have a computer connected or anything. I can just look and see, okay, I can turn it until it comes on. That's too much. That's my warning light. I need to back off. Okay, I need to back off. So, what are the conditionals that we know? Well, we can say some variable that's greater than a number. We can say some variable equal to some variable greater than a number. Oh, you can't see what I'm doing here. I'm so sorry. I hate it when I do that. I really do. Okay, so what conditionals have we learned? The conditionals in the if statement go inside of the conditionals in the if statement go inside of parentheses. One is you can have a variable greater than a number as your conditional, or you can have a variable less than a number for your conditional. What would be another one? Another one would be equal. Okay, so let's try that. What we're going to say is that if V2 equals, but you know what? And this is like the #1 problem that I see in helping students find mistakes in their programs. The conditional for equal when it's inside of an if statement is equal equal. If you just said if V2 equals 4, Arduino says, I guess he wants to make V2 equal 4, and it would put 4 in the variable V2. It would change V2. Just like when you say V2 equals, it changes V2. If you say V2 equals here, it changes V2. So for a conditional, you don't say V2 equals, you say V2 equal equal. And when you say equal equal, it's like you're asking a question. So if V2 equal equal, let's make it 5, turn the light on. And now here, to turn it off, it would be if V2 does not equal. How do you write does not equal? That is the exclamation equal. So exclamation means not equal. So if V2 equal 5, you turn it on. If V2 does not equal, you turn it off. So let's roll that down. And then I do think that we will look at the serial monitor again here. Okay, so that's 3.4. and then we're going to turn it up, and I can't quite get it to 5. That did not work. Okay, let's see what I did wrong. What if we set if V2 equal 5? I hate it when my programs don't work in real time. Okay, that is that, and that is not coming on. That is not coming on. Let me look one more time, and then what I am afraid is, I'm afraid that I am comparing a float to an int, and you really can't. Floats aren't exactly equal to anything, and so I think that is the problem. Let's do it this way. If read val, which was this up here, if read val equal 1023, I want to make this work, and I'm embarrassed that it didn't work, but I just kind of make examples up as I go, and then I am sad if they don't work. Okay. Still the LED is not coming on. Do you guys see what I'm doing wrong? Did I miss something? Red pin is 9. Okay, let's see. I said 1 is... That was what my problem was. Did you guys see that, or... Let's try this now. Did you see that I was turning it on here, but then it would immediately turn it off there? And I think that was the problem. Okay, let's try one more time. 5, and it is still not coming on. I hate these types of problems. So if, oh, read val. I need to go back to V2. Are you guys yelling and screaming at me? I really hope you are. But you know, I do these problems kind of in real time, and I sort of am making the problems up. Okay, 5, and boom, it is on. If I turn it down, boom, it goes off. Okay, the point of all this was to show you conditionals. All right, so if V2 equal 5, it turns on. If V2 is not equal 5, it turns off. All right, I need to look here to make sure that I tell you right, because you know what the problem is? I do a lot of different programming languages, and sometimes I forget what the right command is. All right, you can do compound conditionals, and that means you can use ands and you can use ors. So let's say if you want to turn the red warning light on if the voltage is between 2 and 3. If the voltage is between 2 and 3, the way you would do that, you would say if the voltage is greater than 2, and in the and is and like that, and V2 is less than 3. So you only get in here if both conditions are true. That is, V2 has to be greater than 2, and it has to be less than 3. In that case, you will turn the light on. Now on this one, to turn it off, you would say if V2 is less than 2. Now, in this case, you would not say and, right? You would not say and, because you want to turn it off either way. So here you would want an or. And the way you do or is these bars, 2 bars. That bar is like shift / on my keyboard. It is above the enter key. So if V2 is less than 2, you want to turn it off. Or if V2 is greater than 2 or greater than 3, you want to turn it off. Do you guys understand the difference between and or? Do you? Okay, let me just take a second and do that because it's a pretty important thing. The difference between and or. All right. So let's understand the difference between and or. If this is A and this is B, what is A and B? Well, A and B have to both be true, and so that would be like that. Only in this region are you in the region of A and the region of B. If you have A or B, that would be everything. Because here it's true because B is true. Here it's true because A is true. It's like A or B. That would be sort of like if you said, you know, would the boys stand up or anyone over 12? It would be girls that were over 12 and it would be boys, all boys, and it would be boys over 12. So it would be all. So and is more restrictive and or is more inclusive. So for turning it off, we want to turn it off if V2 is less than 2 or if V2 is greater than, or if V2 is greater than 3, an or. So these are compound statements where you can or conditionals together or you can and conditions together. So if this works right, if I'm thinking about it right, the light should turn on between 2 and 3, and otherwise it should be off. Oh! What happened here? Oh, were you guys yelling at me? What's wrong? Uppercase V. There's a difference between uppercase and lowercase v, and that was the problem. Problems like that are really hard to debug sometimes. Okay, it is happy. Let's get our serial monitor open. Okay, 4.79, the potentiometer is off. That's good. Let's turn it down. Tension builds, tension builds, tension builds. Boom! Under 3, the warning light came on. If I go back above 3, boom, it goes off. Now let's see if I can get all the way, boom, it's on, and now I go a little under 2, and boom, it is off. Do you see the power now? We've done kind of, it's been kind of slow learning certain things. It's been kind of slow for us to learn how to just get things going and how to do circuits and stuff. But all of a sudden, this is a really powerful thing. I mean, you can imagine applications where you would want to warn a person if they were in certain ranges without having a computer or a computer screen. We could run this Arduino off of a battery, and then we could get a warning if we are in this danger zone. Okay, so let's go back and let's think about what we learned. We learned greater than, we learned less than, we learned equal, and we learned not equal. There, of course, you could imagine there is also, you could do less than or equal, you could do greater than or equal to, and in that case it would just be the equal goes second, less than or equal to, greater than or equal to, so it would be greater than or equal to, less than or equal to. You could put greater than or equal to, you could put less than or equal to, and that just kind of changes how it behaves at the boundary, but it recognizes though. So we know equal, not equal, we know less than, greater than, less than or equal to, greater than or equal to. We also know and, which is and we know bar, which is or. So now you know all of these different conditionals. This is your assignment. I have an assignment for you. Go back and look at your little handy thing of LEDs, okay? And what I want you to do is I want you to do a project where you have 3 LEDs, okay? 3 LEDs, not 1, but 3. How many pin modes are you going to need? 3. How many resistors are you going to need? 3. How many how many LED variable names you're going to need? 3. But what I want you to do is hook up a green LED, a yellow LED, and a red LED. And here are the conditions. If the voltage is under 3 volts, I want the LED to be green. I want to have a green LED turn on indicating, hey, you're in the safe zone. Everything's okay. But if you are between 3 and 4 volts, what I want you to do is give a warning, which would be a yellow LED. And then if you get above 4 volts, then what I want you to do is, above 4 volts, I want you to turn the red LED on. Now, the kind of tricky part about this is, again, you've got to remember that, like, if you're in this zone of 3 to 4, where you turn the yellow on, inside that if statement, you've got to make sure that you turn the red off, and you've got to make sure that you turn the green off. So inside of those if statements, you have to make sure that you are turning the other LEDs off. And so this is going to be easy to hook up, but you're really going to have to think about your if statements, because you got to think about how to turn those LEDs off as well. Okay, guys, this has been a really fun project. I think it's been an important one. I hope you have enjoyed it as much as I have. I hope you will give me a thumbs up. I hope you will subscribe to the channel. Love to hear your comments down below, because, man, I just don't know. Is anyone even watching these things? Does anybody just do these projects, or am I just talking to the wall? Put your comments down below also on the homework, right? I want to know, are you guys able to do this? Am I giving you something that's too hard, or have I taught you enough where you can figure it out? You see, this is a problem. If I just give you a homework like, oh, make a blue LED turn on when it's between 1 and 2. That's like almost exactly what I showed you, but I want to show you something, and then I want to give you something different and see if you can figure it out. Okay, Paul McWhorter from TopTechBoy.com. I will talk to you guys later.